Let's solve logarithmic equations. And when we solve a logarithmic equation, the best advice I can give you is turn it from a log into an exponent. And when we solve exponential equations, we'll actually go the other way. We'll turn it from an exponent to a log. So what we're really going to be doing is just switching forms. The very first problem says log base 2 of x equals 7. Well, I wonder what x is. I wonder what numerical value this could have. Log base 2 of what gives me 7, and 7 is the exponent. We're going to turn it from a log into an exponent. So 2 to the 7th equals x. You can draw it all kinds of ways to remember what goes where. But basically we're going to have 2 to the 7th equals x. It's just our way of rearranging things. 2 to the 7th is 2 times 2 times 2 times 2 times 2 times 2 times 2. That's 128. I'll save you the trouble. You could use a calculator, but you know, that's why we have brains, so we can do this without a calculator. All right. The second problem says log base 3 of x minus 2 equals 3. And we're going to do the same thing. So a lot of these are very similar. So as you're going through this video, if you're watching this and you're like, oh, I just want to try this on my own, then do it. Please try it on your own. So we're going to do 3 to the 3rd equals that. And so it's a very similar process. 3 to the 3rd equals x minus 2. And we're going to find out what 3 to the 3rd is. It's not 9. It's not 3 times 3. It's 3 times 3 times 3. There are 3 3's that we're multiplying. 27 equals x minus 2. We're going to add 2 to both sides, so we have 29. So there we go. We've gotten the first two problems out of the way. And with those first two problems, we've done this biggest step that we need to do, turn it from a log to an exponent. So, process continues. Very similar idea as we move forward. So the next problem says log, no written base, I hope you know what that means, 2x minus 3 equals 3. So log base 10. Understood 10 down here. So 10, log base 10 of something gives me 3. And I don't know what that something is. So 10 to the 3rd gives me this whole expression. So 10 to the 3rd equals 2x minus 3. I'll find out what 10 to the 3rd is. Well, 10 times 10 times 10. 10 times 10 is 100, times 10 is 1,000. So 1,000 equals 2x minus 3. We're going to add 3 to both sides. We have 1,003 equals 2x. We divide by 2. We have 501.5, and that is equal to x, and we're done. We finished. We found out what x is. If you want to check it, you could. You could say, well, let's find out log, I'm not going to put the base 10, 2 times 501.5, let's put it times like that, and then minus 3. And if you were to type this in your calculator exactly like that, you'd get 3. It would work. It does work. So there are ways of checking them as well. You can just plug it back in and make sure it works. So as we continue, we're going to get into some different types of problems. The next one actually is quite different, and you'll see what I mean in a second. So here goes. Log base x of 8 equals 3. And I don't know what x is. So log base something of 8 equals 3. I don't know. Maybe you know what it is off the top of your head. Lucky you. But x to some power, x to the 3rd power gives me 8. X to the 3rd power gives me 8. Now I don't know what x is. So something to the 3rd power gives me 8. Okay, maybe you know the answers too, maybe you don't. But if we're solving this, now the process is different on solving. And when I look at this, I say, well, you know what? I have an exponent of 3 and I need to undo that. So the best way to undo an exponent of 3 is to take a cube root. So we're going to cube root this and cube root that. So we're going to cube root 8. And again, you may know the cube root of 8 is 2. And if you don't, that's okay. Basically, these cancel, and you're left with x equals. And you can type that in the calculator. In case you need to know where it is, I'll show you very, very quickly. What we're going to do is press math and see the little cube root right there. There it is, cube root of 8. We can type that in, and we get 2. If you didn't see it, just press math. It'll be obvious. So x equals 2, and that's it. We got it. We found it. We're done. Okay? So that one was similar in that we're taking it from a logarithmic form to exponential form, but it took a different process of actually solving it. Okay, let's move on. The next one is a very similar idea, very similar process. I wrote the 4. Put the 4 in the wrong place. Or did I? See what I mean in a second. I just blurted out the answer, actually. The answer is 4. And now that you know the answer, you may have lost your motivation, but that's okay. X to the 4th equals this, so x to the 4 equals 256. And I want to know what to the 4th power gives me 256. What, when I multiply it by itself, and there are 4 of them, will give me 256? Well, if I want to undo x to the 4th, then I should take the 4th root. So let's take the 4th root of 256. And that looks kind of sloppy over here, but basically this is x equals, well, something. And I'm actually going to type this one in the calculator as well. I want to know what this is. So here goes. I'm going to press math, and I'm going to go down here to the xth root. I'll press enter. And so the root I want to take is 4, and the 4th root of 256, and we got it. It's 4. So indeed the answer is, well, 4. So we found it. Lucky us. So x equals, well, 4. And so that kind of takes us to the end of, well, the first 5 problems, but the first few problems that don't have too many little tricks in them, and we had to take a root in there, and it wasn't too bad. The biggest idea, though, of how we're going from logarithmic to exponential is going to remain as we go. However, it's going to take a few more steps. So let's erase the whole board. The board's only so big. And we'll move on to the next one, and we have a couple options on this one. So let's see. 2 log base 2 of x equals 10. So 2 log base 2 of x equals 10. Okay. So we have dealt with the properties of logarithms, and one of the properties of logarithms is that if I have a coefficient, I can move it up and it becomes an exponent, which means the next step looks like this. And I'm going to proceed with this, but then I'm going to show you a different way very quickly that might be a little more efficient, but it's good practice. So log base 2 of x squared equals 10. Okay, so I'm going to do 2 to the 10th, and it's going to equal that. So 2 to the 10th power equals x squared. And I want to find out what 2 to the 10th is. And then when I'm done, well, I'm not done because I need to find out what x is, and x is squared, so I need to take the square root of it, and anyway. So here's what's about to happen. We're going to find out what 2 to the 10th power is, and it is 1024. 1024. Sounds like a game, doesn't it? So 1024 equals x squared. Well, that's what x squared is. I don't care what x squared is. I want to know what x is. So I'm going to take the square root of 1024, and when I do, I'm going to get 32. Okay, so here's what just happened. I took the square root of both sides, and I got 32, and there it is in the calculator if you need to see it. But here's another way, and this way that I'm about to show you works this time. It may not always work, but it's going to work this time. Here, let me switch colors. And same problem, different way. You can write it or not. That's up to you. So 2 log base 2 of x equals 10. And back in the day when you were first learning to solve, your teacher would say, well, you know what? There's a 2 in the front. Let's divide. We're multiplying by 2, so we'll undo it with division. So log base 2 of x equals, well, 5. And 2 to the 5th equals x. So 2 to the 5th equals x. It's just a little bit simpler. The numbers are a little smaller, in my opinion. 32 is x. So like 2 to the 5th is 32. We got the same answer. We just did it a different way. Now, why doesn't this always work? Because if I had more than one log, then I'd have to divide the other log by that, and then I'd have something. You might see it in a minute. But for now, don't worry about it. You could do this either way. And both ways are good. I prefer that one, but that's just a matter of opinion. I don't get paid for my opinions. So the next problem is kind of similar to that, but it doesn't have to be done the exact same way. I'm gonna do it the way I want to do it. So 1/2 log base 6 of x equals 2. Okay, so the obvious thing is, well, this 1/2 comes up and it moves up here and it becomes a square root. It's x to the 1/2. X to the 1/2 is a square root, and that's cool. And so your next step could say this. You don't have to write this if you don't want to. And then you say, oh, that's really this. And it's beautiful and it works. It's great. And then you go 6 squared. I'm almost done with that, but I do want to show you the other method that I just did. But I want to show you a different way because this one's structured a little bit different. Structured differently, I would like to divide by that 1/2. Don't write this, it's right, but it's sloppy and inefficient. We could divide by 1/2 and it cancels those, but no one likes to divide by fractions, right? So that's why we multiply by the reciprocal of something. So if I have a 1/2 here, it's the same as getting rid of 1/2. I could divide by a 1/2, or I simply could just multiply by 2 and multiply by 2. And when I do, well, this 2 cancels with that one, and I have log base 6 of x equals 4. And now, smooth sailing. I'm going to just take, I mean, that was like a sailing metaphor. What I'm going to do is, sorry, turn it from a log into an exponent. So 6 to the 4th equals x. I'm going to take my first advice that I ever gave you, turn it from a log to an exponent. So find out what 6 to the 4th power is. And I don't know that off the top of my head. 6 to the 4th, I almost typed 6 to the 44. That's not good. 1,296. So 1,296 is equal to, well, x. And we found it. Okay? Now, as we move on, things are going to get a little bit different because the next one's going to be like really straightforward. Very straightforward. And even though it can definitely be done with a calculator, I'm not going to because it's very doable without a calculator. All right. Switching colors, no reason. Log base 64 of x equals -3/2. Okay, well, let me tell you what I don't see. I don't see a coefficient in the front. It's understood 1, so I could move it up, I could divide, but there's nothing to move. So that step is not relevant. I am going to turn it from a log into an exponent. So 64 to the -3/2 equals x. So 64 to the -3/2 equals x. Grab a calculator, type it, cool. But you're going to get a mess. So I want us to kind of figure this one out just using some skills we know about exponents. So negative exponents move things from the numerator to the denominator or vice versa. And this is one big fraction right now. It's all over 1. So what we're really going to do is just put this in the denominator. And there's a 1 on the top because everything's multiplied by 1, right? And then if I have a denominator of my exponent of 2, it's a square root. That was super wordy, but remember a minute ago we had like this, and we're like, oh, it's really a square root of x. This is really the square root of 64, right? And that's equal to x. Now I've left something out, we'll fix it. We'll fix it in a second, but right now I've taken care of that 2 and said, well, it's really a square root. Well, it's also cubed. Now it's right. Okay, let's bring the work over here. 1 over, well, the square root of 64 is 8. So 8 cubed equals x. And now I'll just find out what 8 cubed is. And it is, I think, 512. Yes. So x equals 512. So 64 times 8 is 512. Yeah, okay. Okay, yeah, I was going to feel ridiculous if it wasn't. But that's it. We found it. Right? I said I wouldn't use a calculator. I was just double checking. All right, so we have found what the actual answer is, but I actually just messed up, and I hope you see what I did. And it was an unintentional mistake. I was so busy focusing on what 8 to the 3rd was that I forgot that the answer is not 8 to the 3rd. I think I grabbed my calculator. I would have moved on without it. 1 over 8 to the 3rd. Be careful. So if you would have been right up here and you would have typed this in your calculator, you would have gotten a decimal. It's like 0.00 something, 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 something. And if you turn it into a fraction, you should get that. Okay, for the next problem, we have 2 logs, and we're going to put them together. And then as we do that, it kind of gets us into a different idea. So we will do that one in the next video.